Here in this video we're going to have a look at an exercise where we employ the discrete Cauchy Schwarz inequality. Let's take the following sequences: ak m to the power of k, bk l to the power of k, where m lies in the interval 0, 1 and l 0, 1, and we don't want m to be equal to L. So these values of M and L should be different. M should be different than the value of L. The Cauchy Schwarz inequality, the discrete form, is the following. Let's take this form of the Cauchy Schwarz. Let's have a look at the left hand side. We have the sum k 0 to infinity, ak bk. M to the power of k times L to the power of k. So we have the sum k 0 infinity. By the properties of powers, we have ml to the power of k. Of course, we know that m is between 0 and 1 and l is between 0 and 1. So the product m times l should be less than 1. That one is less than 1. So we can... this is basically an infinite geometric series, and we can write 1 over 1 minus m times l. So the left hand side is... the left-hand side of the inequality is 1 over 1 minus ml. And the product ml should be different than 1. Now let's work out the right-hand side of the inequality. We have the sum k 0 infinity ak squared to the power of a half. So we have m to the power of k squared, and that is the square root. And we take the square root of that quantity. M to the power of 2 and the whole to the power of k. And that is an infinite geometric series, is 1 over 1 minus m squared, square root of that, so that's going to be 1 over square root of 1 minus m squared. And then we have the sum from k 0 to infinity, bk squared to the power of a half. So that's L to the power of k squared, and that is to the power of a half. So that's L squared to the power of k and square root of the whole thing. That is an infinite geometric series. And we have 1 over 1 minus L squared, square root. So the final conclusion is that this quantity here equals square root of 1 over 1 minus L squared. Now let's combine all the quantities that we have computed explicitly. So the left hand side is less than the right hand side. And from here we have 1 over 1 minus ml less than 1 over square root of 1 minus m squared times 1 over square root of 1 minus l squared. That's my final inequality. Of course, the values of m and l are different between each other, and m is between 0 and 1 and l is between 0 and 1. So this is a nice exercise because we can obtain a lot of various inequalities by using this. This is the discrete Cauchy Schwarz inequality. And basically, by using these sequences where m and l are quantities strictly less than 1, basically the left hand side of the inequality is an infinite geometric series which can compute it explicitly. We have computed it explicitly here. Then we can compute the quantities that are located in the right hand side of the inequality. So here again we obtain an infinite geometric series. We compute it explicitly. That is given here at this point. The sequence bk, we take the sum from 0 to infinity, is an infinite geometric series. So L is less than 1, the square of it is going to be less than 1, of course. We compute this infinite geometric series, and this is nested inside the square root. We combine all the above quantities, and we get the bound that the left hand side is bounded by the right hand side, and we derive this final inequality here.